Welcome to Module 8. Today we dive into one of the most transformative aspects of the modern airline engineering supply chain, digital transformation. Let's begin by understanding what this term actually means. Digital transformation refers to the strategic use of digital technologies to change how we operate, how we deliver value, and how we ensure efficiency and safety across the supply chain. It's more than just implementing new software. It's about rethinking processes, integrating data, and enabling better decision-making. Why is this important for airline engineering? Airlines operate in high-cost, highly regulated environments. A single grounded aircraft due to a missing part can cost hundreds of thousands of dollars per day. Delays in maintenance or logistics can result in a cascade of operational and financial issues. Digital transformation aims to tackle these problems. It enhances visibility across the value chain, speeds up response time, enables predictive maintenance, and supports smarter inventory and logistics decisions. This is especially vital as we balance efficiency, safety, compliance, and cost. Let's now explore the major technologies powering this digital shift. First, IoT. In aviation, IoT involves embedding sensors into aircraft components. These sensors collect real-time data such as engine temperature, tire pressure, brake usage, or flap cycles. This data is transmitted to maintenance systems where it's analyzed for wear and tear. An example is Rolls-Royce's engine health monitoring system, which uses IoT to detect anomalies and schedule proactive maintenance. Second, we have big data and predictive analytics. Airlines collect massive amounts of data from flight operations, MRO systems, weather, and parts suppliers. Predictive analytics uses AI to process this data and forecast part failures before they happen. For example, by analyzing trends in auxiliary power unit, APU performance, airlines can preemptively replace a unit before it fails mid-flight. Third is artificial intelligence and machine learning. These technologies support smart inventory management. For instance, by learning from historical demand patterns, AI can predict when and where a specific rotable will be needed, thus optimizing stock placement. Lufthansa Technik uses AI to manage inventory for over 100,000 different part numbers. Digital twins create virtual replicas of aircraft or components. They simulate real-world conditions to forecast deterioration and reliability. With this, engineers can test scenarios such as how different weather conditions affect flap mechanisms. Airbus uses digital twins in fleet planning to enhance performance reliability. Blockchain offers secure, immutable records of part history, usage, and origin. This is especially important for leased parts, where accurate usage data is needed. For example, blockchain can trace a used part from an A320 that's been across 5 lessors, ensuring full compliance and airworthiness documentation. Modern MRO systems such as AMOS, Ramco, and SAP S/4HANA allow real-time integration between maintenance, supply chain, and finance. Cloud platforms ensure that updates in one area are instantly reflected across all systems. This reduces error, duplication, and inefficiency. Lastly, Arkansas and mobile technologies are empowering technicians with visual guidance. Imagine a technician using AR glasses that overlay torque values or bolt sequences directly on the component they're working on. This improves task accuracy and reduces turnaround time. Let's bring this to life with some real-world examples. Qatar Airways integrated predictive analytics into their heavy maintenance C-check planning. Using SAP, they were able to identify high-risk components in advance. This reduced unscheduled maintenance events by 15%, translating to improved fleet availability. Lufthansa Technik deployed digital twins for their A320 fleet. These twins simulate component fatigue and usage, allowing engineers to better plan component removal and refurbishment. This resulted in better reliability and improved customer satisfaction. Delta introduced IoT in its MRO shops to track tool compliance, torque application, and technician signatures. This digitization has not only improved safety, but also reduced audit times. JetBlue's maintenance teams use tablets integrated with task cards and manuals. This eliminated paper logbooks and sped up task closure rates, especially during A-checks. SIA Engineering adopted drone-based inspections for visual checks in hangars. These drones cut down the inspection time for wide-body aircraft by almost 30%, a significant reduction in turnaround time. How do we implement digital transformation? We follow a structured roadmap. Digital maturity stages. We start at the initial stage, manual siloed systems, then move to emerging, where digital tools exist but don't talk to each other. At the established level, integration begins. Optimized is where we start seeing predictive automation. Finally, transformed is a fully digitized, data-driven environment. Assessment. First, we assess our current state. What systems do we use? How do we track parts? Where are the gaps? Engagement. Next, we engage stakeholders from engineering, IT, and supply chain to co-create the vision. Data standardization. We clean up our data, standard formats, accurate part numbers, correct historical logs. Technology selection. We choose ERP or MRO systems that align with our needs. AMOS, Ramco, SAP. Pilots. We run pilot projects, say tracking breakware with IoT sensors on one fleet. Scale up. If successful, we scale and embed the change through agile processes and regular reviews. Governance. It's crucial to set up a digital steering committee that meets monthly, tracks KPIs, and adjusts course as needed. Digital transformation isn't without risks. Digital risk. What if someone hacks into our inventory system and manipulates stock levels? Or what if we invest in a vendor whose technology becomes obsolete in 5 years? Cybersecurity. To counter these, we enforce encryption, two-factor authentication, and secure APIs. We also run drills for data breach scenarios. Compliance. EASA and FAA have clear guidelines on digital records and aircraft maintenance data. We must ensure our systems meet these requirements. Change management, but perhaps the biggest challenge is people. Technicians may resist tablets, or planners may distrust AI forecasts. The key is communication, training, and showing early wins. Create digital champions across departments and celebrate milestones. Looking ahead, AI co-pilots might suggest inventory plans. Autonomous robots could deliver parts inside warehouses. Advanced 3D printing might allow us to print cabin parts or air ducts on site. Machine learning will not just optimize inventory but also help model entire fleet strategies, like when to retire, lease, or upcycle aircraft. Discussion prompts. How do we ensure our digital journey aligns with safety regulations? Where do you see the biggest opportunity for digital impact in your supply chain? What are the most useful KPIs to measure digital ROI? Conclusion. To wrap up, digital transformation isn't a destination, it's a journey. It's about using data, technology, and teamwork to build a more agile, efficient, and resilient airline engineering supply chain. Start small, scale smart, and stay aligned with your operational goals. Thank you, and see you in Module 9, Supplier Relationship Management in Airline Engineering.